Hello, this is Geometry. We're going to preview the 4-4 to 4-5 proofs packet. Before we formally go through these triangle congruence proofs, we're going to just go through marking up the picture and figuring out if we would prove the two triangles are congruent by side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side. So we are just going to be marking up the pictures with the given and then coming up with a conclusion of which one that would be. Then you'll formally go through the proofs packet and work a bunch of proofs to get practice. Let's look at number 1. We're given that angle K is congruent to angle M, and the line segment JK is congruent to line segment JM. We are also given that JL, line segment JL, bisects an angle. So angle KLM. So from K to L to M. If we are bisecting an angle, you're going to mark up the angles. So these two angles are congruent. Make sure you understand that these two angles have a different tick mark than those two angles. So this is, by definition of angle bisector, those two angles would be congruent, and just by given the other two corresponding angle pairs and side pairs are congruent. So the two triangles would be congruent, and I will make my conclusion using red pen, what you would eventually prove. You would prove that the two triangles are congruent by side, angle, skip a side is fine. You can skip a side or an angle, and an angle. Or angle, skip a side, angle, side. So we would prove that the two triangles are congruent by angle, angle, side. You can also call that side, angle, angle. Let's try the next one. So we're not going through the proofs. We're just talking about how you would prove that triangles are congruent. So let's look at number 2. Number 2, we're given that the two sides are perpendicular. BD is perpendicular to AC. Whenever you see perpendicular in a proof, you will have 3 steps in a proof. Right now, we know that perpendicular means right angle, so we're going to mark that in. In the proofs, it would be, by definition, a perpendicular. Each angle is 90 degrees. And since each angle is 90 degrees equals 90 degrees. So the two angles equal in measure, and then by definition of congruence, the two angles are congruent. But right now, we're just marking up our picture. We're also going to mark up that if line segment BD bisects a line segment, then you're going to mark up the line segments. In problem number 1, we bisected an angle, so we marked up angles. Here we're going to mark up side lengths. So AC has been bisected, so those two segments are congruent. And you would do one more thing in here. You would, so by definition of segment bisector, those two are congruent. You would also say by reflexive, BD is congruent to itself. So the two triangles are congruent by side, angle, side, side, angle, side. I like to write it for both of them, making sure that they have the same order. So yes, those two triangles are congruent by side, angle, side. Let's look at number 3. R is the midpoint of line segment QS. So let's go ahead, and I'd like to color code. I think it's really important. It's not necessary, but it's really important. If R is the midpoint of QS, then QS has been cut into two congruent pieces. So by definition of midpoint, those two pieces are congruent. And it's also R is the midpoint of line segment PT, so I'll use a different color for PT. So if R is the midpoint of PT, those two segments are congruent by definition of midpoint. You would, in addition, mark the vertical angles are congruent. So by the vertical angle theorem, those two angles PRQ and TRS are congruent. Therefore, the two triangles are congruent by a side, angle, side, side, angle, side. Okay, so we're not formally proving these, we're just talking about how we would prove them. Number 4, the triangle is equilateral. Well, I want the two little triangles to be congruent to each other, so all I have to mark is definition of equilateral. Those two segments are the same. This segment is also XZ is congruent to the other segments, but we don't have to mark that for this. If WY segment bisects an angle, then by definition of angle bisector, angles are congruent. So let's go ahead and mark angles. Angle XYZ, from X to Y to Z. So we're going to mark those angles. So by definition of angle bisector, those two angles are congruent. We would also mark by reflexive that YW is congruent to YW. Therefore, the two triangles are congruent by side angle side. Side angle side and side angle side. Let's go to the back side. Given that angle N is congruent to angle L, so we'll mark those. And line segment JK is congruent to line segment MK. We can also mark oh, why did that just erase? I'm not sure. So we have angle N and L, JK and MK. And then we also can mark this is so strange that it is erasing on me. We can also mark these angles by the vertical angle theorem. So the two triangles are congruent. Again, not sure why this is erasing. The two triangles are congruent by an angle side and an angle side. Okay, let's try the next one. S is the midpoint of QT. So again, I would mark up QT. So those two pieces are the same. And whenever you see parallel, go ahead and draw in your red. So we have QR with the arrows are parallel to TU. And then we have transversals. We have the blue transversal and we have a green transversal. So we're going to mark up angles that are congruent to each other by alternate interior angle theorem. So red and green angle is congruent to red and green angle by the alternate interior angle theorem. So whenever you see parallel, you'll use alternate interior angle theorem. Moreover, when you see blue and red, those are congruent by the alternate interior angle theorem. We are now ready to prove these two triangles are congruent by angle side and angle side. Okay, number 7. AB is congruent to CB. So AB is congruent to CB. And D is the midpoint of line segment AC. So line segment AC. So if it's a midpoint, we're going to mark up sides. So midpoint, by definition of midpoint, those two pieces, those segments are congruent. We can also talk about reflexive. So by reflexive, DB is congruent to DB. So the two triangles are congruent by side, side, side. Number 8. Lastly, let's see if you guys can follow with me pretty well on this. So first of all, XY is congruent to WZ. Whenever you see the parallel, you should think I'm going to use the alternate interior angle theorem in the proof. So I'm going to mark those two segments with red pen and show that they're parallel. So YX is parallel to ZW, and I'm going to use my double arrows, or you can just use one pair of arrows is fine, to show that those are parallel. We're going to draw in a transversal. So the transversal, and so we're looking for the blue and red, and blue and red. So the angles that have sides that are blue and red. Therefore, the two triangles are congruent by side angle side, because we also have a reflexive. So side angle side, and here's side angle side. Hopefully this summary is helpful as you approach your actual proofs packet for 4 and 4, 5 when you formally prove different things by using the triangle congruence theorem. So in summary, you're going to prove by using side, 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 angle, side, angle, or angle, angle, side. You prove triangles are congruent by one of these four. Once triangles are congruent, then you can say that angles are congruent or corresponding sides are congruent by CPCTC, by corresponding parts of congruent triangles are congruent. Once you establish that the triangles are congruent, then corresponding sides are congruent. And those are the ideas of proving triangle congruence C's using this method. Hopefully you guys kind of understand this. You'll get a lot more information when you guys actually do the packet. Hope you guys have a good time, and I will see you guys later. So come and ask questions.